Hello everyone, thanks for joining. Uh, we will be presenting our webinar on converting habitable spaces to COVID spaces, which is powered by Searcho. So we have Mr. Nishant Gupta. I just quickly give a very small introduction of Nishant. Mr. Nishant Gupta is ASHRAE's certified clean room professional mechanical engineer and postgraduate in business administration. He is an active member of various societies and is currently chairing ASHRAE's Technical and Standards Committee for Evaporative Cooling System and National Treasurer for ASHRAE. Mr. Gupta is also president of ASHRAE Western India chapter and professionally involved in his company Degree Day Private Limited, which specializes in manufacturing of clean air technology products of HVAC market and designing of challenging HVAC system for built environment. Now today, during our webinar, uh, we will be talking about, I'll quickly explain that what is the objective of this webinar. We will be understanding concerns on air that we breathe, understanding of basics of active and passive filtration, how to select and compare air purifiers, and we will be having the awareness on ideas to implement air purifier for commercial, institutional, hospitals, clean room spaces. Uh, in addition to this, I would also like to give an introduction of Searcho. Searcho is an industry-specific search engine which provides uh, an unparalleled user experience through which we can search for equipment manufacturers, contractors, labor consultants, system integrators, retailers, dealers, and service providers in HVAC industry. Also, uh, we can share. You can share inquiries and get quotes online from multiple suppliers, vendors, service providers in your area for your requirements. An initiative by ASHRAE, Searcho aims to nurture, make, and serve in India, drive and provides an integrated platform focused on HVAC for connecting buyers with the local players like you from across India. We invite you to be a part of this movement, which brings together the industry experts in construction, expands their reach, and fosters mutually beneficiary affiliations. Uh, now, Mr. Nishant is going to share an informative talk on converting habitable spaces into COVID safe spaces.
Thank you, Mohit. If you can give me the cPanel access, please.
Sure. I have given you the access, Nishant.
Okay, so good evening, friends. I hope I am loud and audible and you are able to see my screen. If you do see, please type in chat box why. I would like to know that if I'm able to get through. Quickly, if you can just type why in the chat box, that will help me understand how we are going. Okay, so welcome all. Today we'll try to spend another 60 minutes understanding the basic fundamentals.
Nishant sir, Jitendra this side, your skin is not visible, it's blank right now.
I'm sorry, just hold on for a second.
Just change the page.
I'm doing that.
No, there is white, blank. But I am making you the presenter again. Just a second.
Please do that.
Done, sir. Please accept. Yeah. Now we can see your screen, but not presentation.
Yeah, just hold on. Is that good to go?
Yeah. Perfect.
Okay. Thank you. So, regret the inconvenience. We are good to go now. So we're talking of converting habitable spaces into COVID safe spaces. All the while, we might have, I can see a challenge. I don't know what's going wrong. Jitendra, you might need to support. Okay, sorry. Yeah, it's good.
It's okay now. It's okay now. Please go ahead.
Okay. So as Mohit has informed, we are talking of understanding the basics of the air that we breathe. Filtration, which is a much talked about subject in last 3 months. I'm sure a lot of you must have already heard many fundamental talk that I'm going to do now. We'll also talk of decoding the air purifiers because there are a lot of jargons which are playing in the market, which confuses both the designer and the selectors, and to understand a specific product which has been designed, conceived for COVID-19 during the lockdown, and it's live now, installed and available for you. So we go back to the fundamental. We must have seen the screen. We all know the kind of particles which are available in the air that we breathe, but just for others who are not aware of, a typical human hair size is 50 to 150 micron in diameter, while COVID virus size ranges from 0.06 to 0.14 micron in the size. Now, COVID is considered to be aerosol when the sizes are well within 10 micron, and the moment it rises larger than that, maybe around 20 micron, it rests down and settles down. Just to give you an example of sizes and have a relation when we going forward, we'll talk of different particle sizes. You must know what is the objective, what is the idea that we are actually working towards the entire project that we are doing. So human coronavirus can actually survive for a few days when suspended in the air, and it varies between 3 to maybe 48 hours depending on the type of surface. As we know that in copper the life is very less, 3 to 4 hours, but in cardboard kind of material it may live for maybe more than 24 hours or even 48 hours. We've been talking of various temperature and RH which is recommended, and the basic reason remains that at the lower room temperature and lower RH, which is say below 50 or 40%, the evaporation happens faster and the aerosol which is containing COVID is becoming airborne and makes the life difficult. The basic fundamentals, we would go back to our kitchen exhaust ducts, and we know that if we have to handle any kind of particles that are generated in the air, it is better to capture it right at the source instead of allowing it to go in the entire space and then take it forward. Before I would take this forward, I would also like to share with all of you that if anytime you feel we need to have an interaction and you want me to stop down, please raise your hand and the team at the back end would make sure that you are unmuted. So please make it more interactive as much as you would like to understand more and interact on that. As we talk on the date, there are close to 11 lakh lives which has been lost across the globe and more than 3.7 crore cases reported. Within India itself, it's about 71 lakh and more than 1 lakh 8,000 lives that have been lost. So there are various talks of evidences that whether COVID is actually airborne. In July, there were scientists who were writing to WHO confirming, and then there was dilemma. Eventually, last week, again, CDC had confirmed this, that yes, it is airborne. And leave aside kind of confusions that we would have. We all know that a basic flu kind of ailments also happens when we are in a closed environment. It's ultimately all those viruses which remains in air, and as long as they are able to achieve that viral count, it might affect the individual. So yes, the chances from getting it transferred through a surface is much more higher, but even in an enclosed space, it remains airborne. So if it is airborne and if we are facing the challenge, what's next? People talk of new normal. We always are now already on the job, and we had been maintaining the social distance which is required. We need to cover our face, of course. We need to basically maintain the necessary hygiene and try to remain in a ventilated clean air. I'm not talking of outdoor air, I'm not talking of fresh air, I'm talking of clean air. We need to ensure the air that we breathe does not contain what we would not like to breathe in. Now, the best way and the easiest way is to ventilate. If we are standing in the open environment on the roads where there's very less population, the concentration of any kind of virus is so much diluted that it does not affect us. But when we are talking in an enclosed space, which is what the cause of concern for the HVAC systems are, we have to have recirculation. We have seen a lot of guidance which is talking of maybe maintaining 2 air changes per hour. There is ASHRAE standard 55 available. There are many various documents of HEPaire and ASHRAE both which talks of the amount of fresh air which is required to have the diluted concentration. The point over here is that how much is good? Is 1 air change good? Is 60 air changes good? Please understand, if you're talking of 2 air changes per hour, we are breathing the same air at least for 30 minutes without that air getting replaced. That means the contamination chances for the individual who is within that space would be as high as within 30 minutes if he gets in touch with that kind of particle. For critical spaces like hospitals, air pressure management is something that needs to be taken care of. We're talking of a COVID concealed spaces, or we're talking of a comfort application of a regular patient who's not affected. Different strategies required for different kind of applications. We need to understand the basic of filtration. Most of you might be aware of, but it's always good to revamp what we have learned and seen. I've broadly classified into passive and active filtration. When we say passive, it is as simple as that you can understand in terms of filters. दिमाग में जब सबसे पहले filter word आता है, छलनी दिमाग में आती है. So anything that collects and withhold any X size particle with Y efficiency. This is something we call it as a passive filtration. While in case of active filtration, there are a huge number of solutions which are available in the market to confuse you or maybe to assist you. There could be electronic waves, there could be ionization, plasma, ozone, ESPs, different kind of processes to either deactivate or to accumulate the particles of varying sizes. Now, very important, whenever you're considering any kind of solution for any space, please undergo these 4 questions in your mind. What is the process that is undergoing in that filtration? What is the efficiency? When I say passive filtration, I can put a 20 micron filter and can also filter 0.3 micron. But what is the efficiency? That could be having maybe 5% efficiency, 2% efficiency, 20, 50, 80, 90, depending upon the grade, the MERV rating of that filter or the EU rating of the filter. Same holds true for the kind of active filtration. So what is the efficiency that the system is working on? And if the manufacturer is claiming that this is the said efficiency, what are the standards that person has been following, or are there any worldwide standards? Is there any validation which is being done by a third party which is neutral? Well, in most cases, you would find the answer to be no. Of course, in passive filtration, it is very well laid norms, and that's the reason that across the globe, if you talk of ASHRAE, REWA, ASHRAE, or even CDC in their guidelines to fight COVID-19, recommends the use of most common methods, which is passive filtration. They talk of MERV 14 rating because anything which is airborne, we are talking of maybe larger than size of 1 or 2 micron. So having a lesser range filter also give you a large level of filtration. But for the ideal case, they always recommend to go with a certified HEPA filter and UVGI, again for the simple reason that this is very widely used, not from today, but from hundreds of years, documented, validated. The results are available on various forums. Now, when we say passive filtration, well, it is important to understand the word HEPA. Very commonly used and wrongly used. The word HEPA is very well defined in EU standards as well as in ASHRAE, also in most standards, which is talking of the efficiency of 99.95 as in case of EU, 99.97 for EU 13 grade I'm talking of. But that is, it will retain any particle size which is having a size of 0.3 micron with the said efficiency. Now this 0.3 micron is the MPPS, which is the maximum penetrating particle size, which means any size bigger than this has a better efficiency. Any size lower than this again has a better efficiency. Now how does that happen? Now when we talk of HEPA, they are basically a kind of paper media which is manufactured using either PTFE membranes or fiberglass kind of membranes, which are having a diameter between 0.5 to 2 micron, and the spaces between them are typically much more than 0.3 micron. Then how does it handle 0.3 micron with an efficiency of 99.95 or 97? Well, in any kind of filters, largely 4 or 5 processes happens. For the bigger size particle, it gets accumulated on the surface by straining, which is typically larger than 10 micron or maybe visible to the naked eye also. That is simple Chalni wala effect. Between the two medias, fiber pores, this will get entrapped. You would have a little larger size particle, which because of its inertia is not able to move. Now maybe the particle size over here is little less, as you can see over here. The inertial impaction would allow it not to change the direction with the airstream, and will get trapped again by getting entrapped on the membrane of the filter. And another one is interception, wherein the particle size is maybe less than 1 micron. Because it is lighter weight, it will tend to flow along with the direction of the airflow, but because of multiple layers of the filters, it will get trapped in one of the second fiber. And the last one, for the lowest size, which is maybe less than 1.1 micron, would move in a Brownian motion. It is so light that it does not have its own specified direction of air movement, and will tend to move in haphazard way. And deeper the filter media or the fibers, it will have larger chances to get entrapped. Or if I may put so, that if it is moving at a very low velocity, it will have a larger chances to get entrapped into one or the other particle. This is an important point you'll understand when we'll go forward on this direction. So any good quality filter, when I say a certified good quality filters, would always have a MPPS specified for it at X velocity and with Y efficiency. So here you can see that particle sizes which are less than 0.1 micron are getting entrapped because of diffusion with the efficiency of 99.9985 or so on and so forth. While on the lower size, the efficiency is actually rising up. You can see that maybe at 0.05, which is the size of the smallest COVID particle, it is getting entrapped almost at efficiency of 100% in single pass, which is not the case for larger particles. And you see that they get settled down when the velocity, when their sizes are within 1 to 10 micron, or they get held because of impaction or interception. That's how you get this bell curve, which indicates the lowest efficiency. So a filter is always defined at MPPS. Very important. You should take it in your heart and remember it forever in whatever type of filtration you would talk of. Another active filtration that we are talking of is UVC. Now, as we know that UVC is nothing but a light which is in the spectrum of maybe between 100 to 400 nanometers. Anything which is less than visible light and higher than the X-ray wavelengths. So within 100 to 400, it falls under this UVC range, and it has the peak germicidal effect at an efficiency of 264 nanometer wavelength. That means that if I'm exposing any organic particle to a UVC light, which is having a exposure of 264 nanometer wavelength, it will have a process wherein it gets inactivated. How does that happen? It's basically when it gets exposed, the nuclei actually disrupts their DNA, leaving them unable to perform any kind of vital cellular function. That means it would not be able to multiply itself. It will not be able to cause any harm to it. And these systems were studied long back in mid of 20th century, and they have been since then recommended as the most common method to kill the viruses if being sized properly. This is a very important underlying fact, if being sized and applied properly. Mohit, Jiten, if there are any raised hand, please do tell me and ask me to stop in between.
Yeah, sure.
Okay, so active filtration with UVGI, we are talking of a low pressure UV lamps, which are commonly being used in this kind of application. And they are typically working with 100% efficiency at 254 nanometer kind of efficiency or the wavelength. So that is the reason that it has an overall effectiveness of germicidal at about 80 to 90% efficiency. So when the lamp is producing 254 nanometer at its peak, while the efficiency is best at 264 nanometer, at 254 also it will have a reasonably good quality of kill rate, I would say, but it will depend on various factors. So what is the right dosage size? Well, COVID-19 virus is comparatively new, and there is no known studies are being done for COVID-19. But yes, SARS and MERS was something which had occurred long back in 2012, 13, and there are a lot of studies done. And COVID also 19, novel coronavirus, is also considered as of the same family. So it is assumed that if it is exposed at a dosage of 10 to 20 millijoules per centimeter square, or say 0.1 to 0.2 watt second per square centimeter, it will have a efficiency with 3 log reduction, which is 99.9% disinfection or inactivation rate under controlled lab condition, which means at a specified distance from the source to the target, at a defined temperature and relative humidity, and at a defined exposure time. So all of this would vary the efficiency of the system. So to size a UVC system, you need to actually consider the effective area, the hidden areas of the space that you need to sanitize or maybe decontaminate. What is the kind of exposure time? Here we are talking of 0.1 to 0.2 watt second per square centimeter. So if you are not able to give that amount of energy, maybe you would like to let the particle get exposed for a larger time, which is not the case when you're disinfecting the air. You have a defined timeline within which it is getting exposed, so you need to have a higher power. But when you're disinfecting the surface, the exposure time is in your hand. So UVC lamp irradiation intensity, of course, that will make a difference, and the distance of source from the target, its adjoining area, what kind of material it is encased into, and what kind of efficiency we are looking at. Are we comfortable with 99 or 99.9 or 0.99? It's a difference of 10 times, a logarithmic reduction which happens. Now, we have been going through many air purifiers. You just Google it out, you visit any kind of digital websites, shopping websites like Flipkart or Amazon or many others, you'd find plethora of air purifiers which are claiming that they are perfect for the job that they're looking at. Let's understand why they are good or bad. So I'll talk of the basic kind of filter which all of us by now are very much accustomed to, which we call it as N95 respirators. Well, N indicates that they are non-oil kind of respirator. That means they are only taking care of the air particles without any oil content, while R and P are not in a similar fashion. When we say 95, this mask have an efficiency of 95% to withhold a particle of 0.3 micron. Now we all know that HEPA filter requires a lot of static pressure. How can a normal person wear a HEPA filter and still continue to have a reasonable, comfortable movement? Well, the fact of the matter is the material which is being used in this is all electrostatically non-woven polypropylene fiber. When you use this kind of material to withhold the particle, it is not because of with the kind of sieving action that is happening or the air velocity or all those talks that we did a few minutes ago, but it's because it is electrostatically charged. So smaller particles would have a higher reason to get retained or get attracted to it. And that is the reason that it has limited life. If you would come back and see a very good quality N95 mask and read the manual that what is the recommended life, invariably you will find that is good for maybe 8 hours, and it's very fast degrades in terms of its efficiency within a couple of hours, and 4 hours, 5 hours, go on, go forth, so forth. So by the end of the day, you would actually not be wearing an N95 mask. This is the kind of media which you see is being prevalent and being used in various companies which are advertising with so-called word true HEPA, multi-stage filtration, 1, 2, 3, 4, 5, 6, 7 stage filtration. They define of different CADR, clean air delivery rate, and they talk of different coverage area. They talk of everything is good about it. They cost you maybe 4, 5,000, 10,000, 20,000, 30,000 rupees. They would give you a very reasonably large coverage area of 2, 3, 400 square feet. They do not sound much. They don't occupy the space. They do everything which is perfect. Then why they are not being used, or have you actually tested that how do they actually perform? Just giving you a simple example, I've taken out the snapshot from one of the social websites where they sell this kind of products, and you would find that This brand indicates a high CADR of 380 cmH with an effective coverage area of 484. Now, when we say CADR, it's actually a term which is being announced by AHM. We'll go back and understand more on it. And it talks of certain air changes per hour considering airfit. That's how it specifies the CADR and coverage area. So if you multiply it and see that actually it requires a 548 cmH to cover that 484 square feet, even if I consider CADR, which is precisely what it should be delivering, which again is a point of question that does it deliver at what speed and at what velocity and what noise and power consumption, various things. But invariably you will find that those things are not matching with each other. So it's all consumer market. You are fed with a lot of marketing terms which are known as true HEPA or HEPA type or HEPA like or HEPA style or 99% HEPA or semi HEPA. So there are multiple words which are being used at, and multiple stages they have been talking of having filtration. Now remember, all these were designed not for today. They were all designed 5 years, 10 years down the line when this PM 2.5 started cropping up. All across the globe, there was requirement to take care of the outdoor air. So you need to size up purifying system to understand what you are targeting is. Are you targeting PM 2.5? Are you targeting smoke, VOCs? You require different kind of systems to handle those kind of situations. If you're talking of COVID kind of scenarios, why these are not good is the reason that you can see for yourself. So a certified HEPA is always classified under European standard EN 1822, which defines the class of HEPA. It starts from E10, goes up to alpha 17, and it shows that what is the kind of retention. So anything which is above H13 is typically, we call it as HEPA, and it has a retention of average particle size of 99.95%, and H14 would have a 99.99, 10 times better than that. So if you see that in single pass, I'm able to retain every particle which is passing by. Why do I need to have 4, 5, 7 stages of multi-filtration? If the filter can work good in one single process, they would never require this multi-staging. CADR. Now, CADR is actually, it was meant to assist the end customer to understand what people are selling. Unfortunately, people have utilized it in a wrong way. CADR is nothing but CFM into efficiency of filtration. So assume that you have a air purifier which is of 1000 CFM, and it works with an efficiency of 85% for 0.3 micron if they claim for that particle size. The CADR would be 850 CFM and not 1000 CFM. So if you know that what is the CFM and CADR, you would be automatically able to understand what is the efficiency of the system. The simple process that has been adopted by AHM, which has specified, which is an Association of Home Appliances Manufacturers back in America, is assuming that a filtration system which is filtering a room of 1008 cubic feet room should, of a height 8 feet height, which is normally the case in a residential kind of application, should be able to clean the air within 20 minutes. So that is the kind of test that they follow, and they specify. So they use a rule of thumb of 2/3. Whatever is the square feet, you divide by 0.66 or multiplied by 0.66, and you know that what is the CADR you are looking at. Now, if you start back and start relating all those companies which are giving different air purifier, you'll start understanding that where the gap is now. And remember that AHM seal is actually utilized to handle smoke, pollen, and dust. So there are individual number which is given for that. That is not meant for virus. And this is something which is wiki facts. So if you just go on Wikipedia and Google air purifiers, you'll get to learn many things that I'm talking of. CDC and ASHRAE. Now we understand that there are challenges. We know that HEPA is one of the best solutions, but why it has not been very commonly used? There must be certain limitations into it. So we know that HEPA would filter a good amount of particles which we are worried upon. It will have a very nice efficiency above than MERV 16, and the filters may not be appropriate for some of the existing HVAC system, because of course we know that they have a huge pressure drop, they require a large space. You would not have that kind of application available. So here CDC and ASHRAE both recommends that you can go for an in-room industrial grade portable HEPA machines or have a pre-assembled system so that you are able to achieve the end result that you're looking at. And CDC also defines a 12 air changes per hour for critical care areas. So now you know that what is the air changes. So when you're doing it with 12 air changes, you're just mitigating your risk. You're now working with 5 minutes, allowing that particle to remain in the air before it gets encapsulated in the filters. If you increase the air changes per hour, you are reducing the risk. If you are using the same air purifier for a larger area, you are increasing that exposure risk. So if you're talking of a critical application like a hospital or places where you are anticipating a lot of people coming in who can have these kind of ailments, it's better that you have a higher air changes per hour. While in case of a comfort application like office or maybe your house or those kind of applications where you feel that the footfall is not having that kind of mix, you can very well consider a lesser air changes, which can be as per AHM as well. So next time when you get across any kind of filtration technology, please look closely and understand what does this true HEPA means. Look for the certification. Look for what level of staging they are providing. Are they also putting an ESP or an ionizer with HEPA? Why do they need it? Because all those things would be actually utilized to withhold the particles. But if they have a gas phase filtration, like maybe a carbon activated filters, it might be used for a VOC kind of case. So again, relook that, are you really worried about the smell which is there, or you're worried about the particle size? Look onto the CADR and decode the filter efficiency. Very easy, check the CFM and look at the CADR. What is the coverage area? Calculate for yourself and decide what size you need to have. Noise is something which mostly, if a X manufacturer would say that my air purifier is rated at 500 CFM and generates a noise of 35 dB or 38 dB, go back and check whether it does it at full speed, because the rating capacity would be at full speed, but the noise would be given at the lowest speed. This is again a big marketing jargon which is being used. And understand whether the capacity is designed at initial pressure drop of the filter, or is it a final pressure drop of the system. As the filter starts getting choked, the system flow rates would keep on reducing and the efficiency of course would get increased, but eventually you would not be getting the same air changes per hour which you have originally designed for. So I am now bringing back to you a small example which one of my friends from Surat did, and he was selling a multi-brand MNC air purifiers and actually did a check for a brand new product of ours as well as theirs. And you can see that very quickly, in case on the right hand side, which is HEPaire, we are able to achieve almost zero particles within few seconds. If you keep it on for some time, maybe within a minute, you will see that the supplier goes to absolute zero. And we have tested results for this. So here we like to introduce the product that we are discussing today, which is HEPaire. Now, how is it different than what the market is offering, or how can it assist you in your system designs? The typical challenges that we all face as a designer or an implementer is, you go to a place where you find that split ACs are installed, you cannot have any ways to put a certified HEPA filter in a aesthetically reasonably good looking manner. You have a ductable kind of system which doesn't have enough static pressure if you would like to add any kind of assembled HEPA filter in the system in line. You do have a air handling unit, but it doesn't have enough space, or maybe the type of fan is not good enough to take care of that kind of filtration needs. There's no space to fit additional air handling units with the HEPA systems. There's no space for ducting, and the client needs urgent solution. It's always yesterday. He's talking to you today. He might take 10 days to finalize the order, but he wants the solution yesterday when he started speaking a day before that. So the system should be cost effective. It should be reusable post-COVID. What will happen to it? It should not affect the aesthetics of the space, or should have the least involvement in the aesthetics, and should have a measurable results. This is what ideally the client would like. And of course, it should not cost heavy on your pocket. So how's HEPaire different? Well, it is a medical grade indoor air quality equipment. When we say medical grade, it contains each and every item which is being utilized to ensure that it does not do what it is supposed to do. Very slim and aesthetically pleasing. It can fit in a width of only 1 feet, which is less than 300 mm. It can actually fit in. And for a space like 1750 square feet, you just require 3 square feet of floor space area. Maybe 3 feet by 1 foot is the space that I'm looking at. It is extremely low in power consumption. It has been sized in a way that The power consumption does not exceed to 75 watts. It's like a plug and play kind of system. You can simply plug it in any 5 ampere socket. It is each and every HEPaire is equipped with UL 900 tested and EN 1822 certified H14 grade deep HEPA filter. It's 10 times better than what you see in a conventional operation theater kind of scenario. The system is sized in a way that it does not exceed 50 dB at its full rated capacity, and even lesser at a lower speed. So it is equipped with a pre-filter which takes care of larger particles, which is G4, so that the loading on H14 or HEPA is less and the life is high. It has a UVGI. Now, technically speaking, even without a UVGI, it will do the job. But to have a UVGI, it will assist to inactivate the particles which are being collected at the source so that they don't multiply and they give an extended life of that HEPA filter. Point one. Point two, whenever you open it up in a year or 2 or 3, you are less prone to any kind of virus exposures. It has been designed for final pressure drop, so the rated capacity is actually less than half of what it's actually delivering at the full speed. And the same unit can be used to create negative pressure. If you're talking of a hospital kind of application, a COVID space, it could be utilized to generate a positive pressure if you're talking of a comfort application or maybe in a hospital case. And it can be used as a standalone air purifiers in a recirculation mode for a comfort application post-COVID scenarios. Very simple. The things does not need to be very complicated. We have not done any great engineering. We have just utilized the basic fundamentals of sizing the fan, utilizing the fan laws, utilizing the pressure drops of various kind of filters which are available. So this unit comprises of one of the world's most advanced EC fans, which is a plug fan kind of thing. So there are no maintenance point. It has a life of more than 50,000 hours and works almost continuously without the need of any mechanical intervention or failure. EC motors is the rule of the game. We all are aware of. It helps both in reducing the energy consumptions at lower speed as well as have a very low sound in the overall process. Filters are the heart and soul of it. Now the filters are available in various media, in various depth, at various static pressure. It depends how you size it. In our case, our initial pressure drop is as low as 10 mm. So we have taken a very huge capacity HEPA filter and sized it for a very low capacity airflow to ensure that it goes on and on and on for a very long time without needing a case for seeking a replacement. I've had a case where we have been designing laminar airflows for operation theaters. My oldest installation, even after 10 years, did not require the HEPA filter to be replaced, and they were getting a perfect count, bacterial CFU count within the limits in that space, in spite of that it was not changed. So if you're using a right size HEPA, it can last really long. The important fact is that they should be properly tested. It should not be a generic HEPA or a true HEPA or a semi HEPA or whatever we may name it. It should come with its own test certificate, which is as per EN 1822 to deliver whatever it is claiming. It could claim less or more. Similarly, when you're using a UV lamp, you need to make sure that it's ozone free. There are UV lamps which are available to generate ozone, and there are others who are made to not generate ozone. It is important that the exposure of UVC should not happen directly on the human eyes, and it is able to deliver the amount of dosage which is required for sanitizing or deactivating the particles. The applications could be huge. You can use it very quickly. It comes on a caster wheel. So while I was talking of various components, it's right to the sizing of the caster wheels. It has been selected to suit for a hospital kind of application, and it is good to be rolled on a surface like a carpet, a wooden flooring, or a tile. So each and every component has been taken care into the concept so as to ensure we achieve the end result. You can connect a fresh air port at the suction of the machine to make the area into positive pressure. You can utilize the room or from the bed suctions and feed it into the section of the machine and convert the areas into negative pressure isolation bed. I would not say isolation room. I'm taking a step ahead and talking of isolation bed. It can filter the room for a normal application like a ICU general ward. Even I've had cases where a regular operation theater where they don't have any option, they've put in that and they've done a third-party test to see that it was actually classifying for ISO class 5 kind of scenario. I have test results, I'll show that to you. And it can be very well used for a simple application like hotels, schools, office, showroom, residence, or any kind of public places. Now, when we talk of negative pressure, we have been told that we require maybe 20 Pascal, 30 Pascal negative in that space. At the same time, we are not sure that the person who's inside that space, let's consider a case of a ICU kind of scenario where you have 20 odd patients inside, they're all suffering from COVID, and you want to make that in negative pressure. You still are not sure the people, those who are walking around, the staff, are they totally secured? Because ultimately, the air is traveling from the patient's mouth to the source of the grill, and it's allowing the air to have those particles suspended in the air. Now, I am talking of a concept of reducing the air which you need to exhaust it out and collect it to the point from where you need to suck it out. So you see that what is the kind of metabolic rate which is applicable in any kind of heat loads or a room. So seated at rest, typically a person would have only 100 watt kind of metabolic rate, and it will increase depending upon the kind of activity. So I'm putting up a point here that while you have to size an exhaust system, we know that 1 ton would give you about 500 CFM or maybe 400 CFM. I've taken on a higher side to be on the safer side as 500 CFM. And I pull back 50 CFM from the face of each individual who's lying on a bed and cover that space. Yeah.
We have a question raised by Mr. Amit Kumar Mittal. He has mentioned that what is the life of a HEPA filter? Can it be cleaned frequently to increase life or use and throw types? What are the alternative cost-effective filter systems when compared to HEPA?
Okay, so sir, unfortunately, across the globe, filters are not meant to be cleaned. They are designed to be changed when they get choked. Now the scenario, as you would understand, I've shown that how does filtration happen. It's not only because of sieving. The moment you wash it or clean it, the entire geometry inside the filter gets changed. So ideally, they are to be replaced. And for HEPA, for sure, they are to be replaced. In this kind of scenario, you can anticipate when you're talking of a clean environment, we are putting a HEPA, you can easily anticipate the life to be well over and about 2 to 3 years. And in an ideal scenario, it can go as high as 10 years also. So the cost of replacement is minimalistic, but the cost of not maintaining is something which could be your life also. Okay, we'll get back to more Q&A. Once I'm done with this, maybe you would get many answers within that thing. So I was referring to a point where I'm asking you to withdraw about 50 CFM from each bed and consider that bed as a small room. Make a negative pressure, and a simple way to check it is burn some incense sticks around the patient and see that where the air movement is, or a demo, so that you know that how the air movement is happening. Now, if you are exhausting 50 CFM, imagine with one small unit of 500 CFM, you can handle actually 10 people and ensure that the particle is not allowed to let loose in the open spaces. And to take care of this 500 CFM, if you do your calculations, you would be able to actually add only 2 TR of split ACs or any kind of treated fresh air units to make up that air. So it's very simple and very fast, and you're able to handle that. So here is the depiction that what I was referring to. You can have a kind of Machardani system over the bed, could be a full bed cover or a half bed cover, and have a small exhaust fan being mounted somewhere near to the face of the person who's breathing, have a transparent kind of sheet so that he's able to see that. And the air which is being pulled in is, say, 50 CFM is good enough in an air-conditioned environment for the person to make him feel comfortable. So here in the case, you have a small air fan, low velocity fan, which is allowing the air to get pushed in, and it's getting sucked in from here and going back to the machine at the suction from where it gets finally exhausted after being treated through a HEPA filter and a UVGI. So this is what the point I'm trying to make. And you can make these kind of simple scenarios. It's very easy, quick to make. You can actually create these kind of places within any convenient conventional rooms, dealer room, or in any kind of loose environments, and make them completely safe for the person who's there as well as for the people, those who are maintaining them. At the same time, reduce the capacities of the system. There are various examples. Now, in another case, we've also utilized a similar concept. What you see on the back over here is a supplier unit. I am feeding the air from a front discharge model into the place where the person is lying inside. Now, this could be a scenario like, say, an AIDS patient develop COVID. Now, you cannot have any outdoor air coming in his respiratory tract because he's prone to get, disease, any kind of disease very quickly. So you need to make that person in positive pressure. So you're pushing the clean air in that area, allowing the air section below the bed and sucking it back and recirculating within that space so that you are able to achieve that. And these are the system which is not I have talked upon during SARS and MERS. It was actually widely used in Southeast Asia. And even today, if you carefully go through the news clippings, I saw the center picture actually in one of the Dainik Bhaskars a couple of months back for a case in Brazil where they have actually used similar kind of scenarios, which helps you reduce your requirement to handle the space in terms of air quantity, filtration quantity, air conditioning capacity, duct sizing, everything. It becomes so much easier for you to handle it. So you can have maybe a cassette kind of application. You can have a small duct running in, put a small negative pressure fan so that you can have an individual suction and push it back up to the section of the machine. The pink ones which are seen in the corner are actually the machine, which is the actual footprint. It's very small, which can in this scenario take care of about say 10 odd patients on one single line and 10 odd on another side, and put some more machines within the space if you want to handle that, whatever little can have exposed particles have exposed into the common areas. This one was designed for a showroom kind of application. So you see this is a jewelry showroom where across the columns you see this is the actual footprint of the equipment, and only 4 of them take care of about 2,500 square feet or 2,000 square feet of the space height, so very less. And you have a central air handling unit. Actually, in another case we are also discussing that you have a small, if you see on the right hand corner, this is the HU room, and the unit can slide in inside the HU room where the return air is getting flooded. You can also utilize a ducted port to connect it to your existing fresh air recirculating air conditioning duct supply so that it gets uniformly distributed and the filtration happens in a flooded way. Another case is for an office application where again these small units which are kept, the pink ones, you can see these are the ones which is kept on any edge near the column and make sure that the space is completely sanitized and clean. It's flexible by design.
Nishant,
Yeah.
4 questions in a row asked by our participants. The first one is, by which mechanism 0.3 micron particles are captured? Is it whether by diffusion? This is the first question asked.
Okay, so 0.3 micron typically is by diffusion. Yes, you're right.
Okay, and then the next question is whether normal cloth masks are preferred over N95. It's a question.
Okay, so Mohit, I would recommend you to please unmute themselves. It's better that they would have any question they can ask in place of you reading it out.
Sure, let me unmute everybody. Yep.
Or otherwise, we would be just concluding it in another 5 minutes. We can have a question answers. If anybody wants to ask now, may please do so.
I have given access to everyone. They can unmute themselves and ask questions.
Okay, thank you. You can unmute yourself, please, anytime you want to. We are on the end of it. Another couple of minutes, I'll finish it off, and then we can open up anytime. Or if you want me to hold, please let me know. So this shows a typical section where port 1 is the suction. It is having a pre-filter which is slidable, can move out. You have a AC fan which pushes the air right up to the UVGI. The UVGI would have a exposure on the HEPA filter which is on the top, and that would allow the air to either move out in the front discharge, which is port 2, or it could have a dummy over here and allow the air to move out, which is in port 3. This can also be used for negative pressure because from port 1 you can have the suction duct connected to the front of it and have the port 3 connected to move out from the room, or could allow it in the recirculation. You can also have a case where you have a room circulation going on and you add a part of fresh air port at the suction of the machine to allow part of the air getting sucked in from outdoor air to add further fresh air. This is a typical sectional view where you can see that this is the pre-filter which can be simply slided out. It is mounted on channels, sliding channels, which will allow you easy access. It can be taken out clean. You'll have access to filters to the fan on the back of it. There's a UV lamp, and then on the top you have a HEPA filter. The top cover, anytime when required to replace HEPA after many years, can be simply unscrewed and can be taken out. And it's on caster wheels, it can be removed from one place to another. These are all, every HEPaire would come with a test certificate of the filter which is being used, which specifies the class and the result, with C certified. And on the right hand side, this was a case where a doctor has actually utilized it for a operation theater, and you can see that the results that were coming was absolute zero of any kind of particles and was classified under ISO 5. So based on, now you know that CFM, CDC and AHM guideline, you can size it for 240 square feet to 1750 square feet. It's available in 3 different sizes in a compact way. The smallest one is Aura, which is little fatter, does not have a UVGI but takes care of the basic requirement of a small space. It has a pre-filter and a HEPA. A Pura both comes in the front and top discharge. In the front discharge, you see these black dots that you're seeing are actually the holes, which is perforation from which the air is moving, and the bottom side is sucking the air inside, and the top port is allowing the air to move out. And it can be utilized in any kind of application that you can think of. We also make many other products, which is largely into hybrid evaporative cooling systems, air distribution products like ducts and grills, and dual stage evaporative cooling systems. So here I am available for you. Any kind of questions, I'll be happy to answer them. Please feel free to ping it now. So if there are any questions, Mohit, you would like me to answer?
Yeah. So I got 3-4 questions altogether from our participants. So the one is that what is C stands in UVC lamp?
So it's the kind of light waves. As we can see that it was A, B, and C. The entire wavelengths are defined in A, B, and C, depending upon the wavelengths that they are in. So if you're talking of within 200 to say 400 nanometers, it specifies C category. It's just the naming nomenclature which has been given.
Thank you very much, Nishant.
Question.
Yeah, please go ahead, ma'am.
Okay. See, the retail stores, of course, have to have a system of installing the HEPaire machine that you're talking of. But our general clientele is residential clientele, right? Who have now come up with queries that, ma'am, can we install a HEPaire filter without making too many provisional, interventions through your other agencies? So, what is
I
the
understand.
minimum provision required to install?
That's right. So for a residence kind of scenario where you're not anticipating a lot of outsiders coming in and going out, you can very well use it as a recirculatory system only, and there's no provision required. You can simply plug and play, put it in any 5 ampere socket and run it to filter the air within the space. I'm using it within my own office space, in my conference rooms and meeting rooms. I've not made any provisions. It works perfectly fine, and I can measure actually the air particles anytime, any point of the day.
And for our running projects, which are under the execution processes, do we have something which can be concealed like an AC, like a cassette AC in the ceilings or wherever?
So you can actually conceal them. As I told you, the dimensions are maybe for a 500, 700 square feet kind of scenario, 2 feet by 1 feet. You can conceal it with any architectural perforation members, and just use it as a part of your interiors. It need not be visible. It just need to have a place from where the air pushes out and comes
Can
in
be
back.
put in any cabinet, any furniture cabinet, right?
Yes, you can do that as long as it has a perforation and it is allowing the air to move out from one direction and allow the air to come in from another direction. It's as simple as that.
Right. And for the retail
Nishant.
stores, I saw one of your jewelry showroom project where you had placed them abutting the columns. You required
Yeah.
a special AHU room. That AHU room was for the HEPA filter machines?
No, so that was a case where it was a centralized air conditioning system. So if you do not want to make it visible to the open air area, you can put it in the
Yeah.
H room. Otherwise, it will work just like an air purifier recirculatory system within the same place.
All right. All right. Thank you. Thank you so much.
Thank you.
Nishant, good afternoon, Chandra here.
Good afternoon, sir.
Yeah, I just have one question on this. The last HEPaire which you are talking about. What is the consistency of performance of this? You know, I do understand. Yes, you have HEPA filters, and then you also have UV lamp. First of all, why both are required? And secondly, okay, even if I take into consideration, yes, both are fine. What sort of a consistency in the readings we get? Because whatever you do, it's definitely not for 1 day or 2 day or one year. It's for a longer period of time. And of course, you also told the life, and you know, there's a good amount of life which you indicated. But I am little concerned on the consistency of the readings. Now, of course, we can take care in terms of the number of air changes and things like that. But what sort of a consistency do you have?
So the consistency would be similar to what any kind of HEPA filter would do it once it is installed. The HEPA filter, you would know, or any kind of filter, would keep on increasing in terms of its filtration efficiency as and when it gets low until it has reached its final pressure drops in flow, where eventually it kinds of breaks up and you are left with the entire exposure to the air. That is the last life of the HEPA filter. So with the kind of depth that is being used in this kind of scenario, it can last for very long. And the easiest way, if you're applying it for a very critical application, is to have a differential pressure meter installed at the door. So you know that what kind of air you are moving out from the space, and is the DPT continuously reducing. You've planned it for 20 Pascal or 50 Pascal, and now after 1 year, it is reduced to maybe 20 or 10 or 5. So you know that the filters are getting choked. That's a simple indication. The consistency of HEPA filters remains unquestioned as long as its integrity remains in place. So when you install it, you can do a particle check, and once it is done, then it is as good as you would do it in any kind of clean room application. So you as a designer would understand that in pharma and hospitals, clean room applications, HEPA had been traditionally used, not now, but from 1940s. So it really remains consistent in terms of its because it's a passive.
Nishant, I'm more concerned on the UV which we are having. Yes, I do agree. HEPA has, especially when you use a standard tested filter, you definitely get the what sort of efficiencies. Especially, I do agree the clean air which is coming out of the HEPA filter at the first point of contact, it will be even, you can say, class 1 to that level we can go to. So, but what I'm looking at is that because of the UV lamps presence which you're giving there, that's exactly where I am looking at.
You're absolutely right. So UV have a life of typically 1,000 hours, and while it is reaching to its end of its life, the efficiency will drop down to about 80%. So that is the time that it needs to be replaced. The UVGI would have inconsistent approach if the filters or the lamp gets dirty or clogged. Now the point here again, which I was trying to make, is that we are not sanitizing the air or decontaminating the air. We are decontaminating the surface for the simple purpose that whatever the viruses that gets trapped in a dark environment should not grow and develop into molds. That is the reason that we have put a UVGI. But as far as the level of sanity of the air is concerned, even if you don't have a UVGI, it would not make any impact because you have the first things right in the first place.
Mr. Nishant? Mr. Ashutosh here.
Yes, please.
Yeah, do they have static RPF control with respect to static to maintain that CFM?
So currently it has a AC fan which is connected to a potentiometer. So through a simple turn knob at a maybe 270 degree, you can change the speed. It has an indication of a green zone or a red zone that you know that beyond this point you need to replace it, but it is not automated, which can be done. You need to have a DPT in place and connected with that. But we wanted to make the system as simple as possible so that the after sale maintenance is minimalistically required. And I believe that, do we have Jitendra with us, Vishal Kapoor?
Yeah, Nishant, I'm here.
Oh, great to have you. So I guess you had utilized it for the first time, sir. In fact, you were the first person who've taken that for a hospital application to convert it into a COVID space. So would you like to share your experience into it?
Yeah, so this was a running hospital which was asked by the government to convert a few wards and ICU for COVID patients. And obviously, we weren't given very much time. And because it was a working hospital, you cannot go around changing the air conditioning system. And as you rightly explained in your presentation, to make it a COVID ward, the most important thing is the negative pressurization. And that obviously means that air conditioning would get affected if we bring in that kind of extra air exhaust out and we have to bring in extra air into the room. It's not possible to handle that. So we used HEPaire in those few wards and the ICU. And what we did was, which was very difficult to convince the customer at the first shot, is that you make each bed as an isolation unit in itself. So we created actually a full PVC kind of a remarcation around each bed. So each bed was isolated in itself, and we had a PVC pipe, like a duct, connected to each bed through an inline fan, got connected to this HEPaire, and then the air was exhausted out. This made the job much easier because the amount of air now we had to handle was much lower as compared to if we had to pressurize the entire room in totality, would have been much more. So we were able to make do with much lower amounts of exhaust air, much faster, easier to install because it's just like a plug and play product. All that we had to do is that we had to create a cowl at the top of the machine to throw the exhaust air outside, which again was not a very big job. And the other advantage was that the healthcare workers in the hospital are feeling much more comfortable because the patient is also within a negative isolation area. Otherwise, when you normally do an existing ward negatively pressurized, you'll have an exhaust at 1 or 2 points, depending on the size of the ward. So you'll have the air traveling in the entire ward before finally it's getting exhausted. In this case, right above the patient's head was our exhaust pickup point. So we had controlled that, connected to this machine. So this machine was sucking air from the beds, as well as we had left out some part of the machine open to also suck air from the room. So the room was also negatively pressurized, but not to that extent. But each bed was very highly pressurized. So, and we've had repeat orders from that same client because at the ease at which it has worked, and the client is operating it, the whole machine, the whole system themselves. We've installed magnetic gauges for them to be a little bit more sure of the pressurization. And till date, it's been, I think, a month and a half more in that, with multiple patients in and out. We've not seen any problems. So we've had a good product at that point to install over there.
Thank you. Thank you very much. So thank you for sharing your experience. Any more questions that remained unanswered?
Nishant, Richie here.
Yes, sir.
Just a question. What is UVGI actually doing? Does it really do the work which it's supposed to do in the system?
So there are no tests which was available for us to check the inactivation level, but we are going by the catalogs and sizing it right to the kind of application that we are designing it at, which are from, again, huge companies which are into, only into UVGI kind of systems. We go by, again, the test results which has been given as a fundamentals for UVGI, and it does talk of inactivation. But till the time we have done an actual test on the surface, and that's the reason that active filtration, we always say that it is not measurable in an open environment kind of scenario. In case of passive filtration, you can always measure the particle counts and you know that what is left. But in case of active filtration, you really don't know that whether it is an activated particle which is coming out of the surface or it is really inactivated particle. That is the biggest challenge. So I go by the fundamentals which has been referred by the various societies across the globe, and they do talk that UVGI is actually effective in doing the job.
Thanks, Nishant. Another question, that the filter, that HEPA filter that you are using, so they are all certified filters. You say it is certified. So how the filters that you are using, like HEPA filter, for example, H14. So just a question, how sure are you about the certification of that filter?
Okay, so very important, sir. The source of this filter becomes the heart of the entire game. If you go with any good quality filter manufacturers, each one of them is having a scan testing facility available. Each filter is labeled with a serial number, and it comes with a test certificate informing the kind of test that it has gone through and whether it has passed the test or not. So you go by those words, and if you go back to the kind of manufacturers we are talking of, they are amongst the finest in the world. So, and then you do a test result at your end after you fix it into the frame, because it's not only the filter, it's the entire fixing arrangement and the integrity of the system. And you do a particle count for yourself to see that whether it is doing the job as it is supposed to do or not. So each and every unit that we make, we do a test in terms of the filtration efficiency which it is delivering at the outlet, to ensure that there are no leakages which is happening across the places.
Thank you,
And then you
Nishant.
come.
Thank you. That's from me.
Thank you.
Nishant, good evening. Madhukar here. I would also just like to share the experience which we had installed one of this. This was in a typical hospital where an ICU was converted to a COVID ICU. So again, we had to create a negative pressure where the customer was wondering about what to do. So what we did was like we installed the HEPaire with a plenum on top, connecting all the 3 ducts, and we just had to take the flexible duct out to make it into negative pressure for the entire area. It was about 1,000. I mean, it's a small area of about 250 square feet. It was converted to a COVID ICU. So in fact, we were also successful, and the time what it takes is just 1 day's time. I mean, just breaking open the wall or making a core cutting of 200 dia just takes about half an hour or 45 minutes, and to make a small plenum and put it back, it doesn't take more than 1 day. And since it's a fit and install kind of an application, I think the kind of work that is involved to make it into a negative pressure zone or a COVID ready zone is much faster when compared to other options that are available.
Right. Thank you, Mr. Madhukar. Thank you. It was a nice experience to know about that. So, are there any questions which are still remaining to be unanswered?
Yeah, Nishant, I have got a couple of questions asked by our participants. The first question is, what is absolute HEPA?
Okay, so what I know of, there is no prefix or suffix. Suffix is there, but no prefix before HEPA. We always grade it on H13, H14, and so on and so forth. As long as the functions is being delivered or it is tested as per the standard, which is LANE and EN 1822, you can name them anyways. I mean, we have heard of names like semi-HEPA, U9 kind of filters people call as semi-HEPA. There's no technical word like absolute HEPA which I'm aware of. These are again to specify. When I say a certified HEPA, is actually also another name that I'm using to classify that yes, this is what I'm actually delivering. But there's no way that unless until you go back to the fundamentals and see the kind of tests that has been occurred and the kind of manufacturing process that has gone into making that filter.
All right, thank you very much, Nishant, for such a brief information on the HEPA, what absolutely it is. Now, another question that we have is, do thin HEPA filters have the same efficiency as the thick width HEPA filters?
Right, so the efficiency for a similar media, so if I'm talking of H14 filter, say one is having 65 mm thickness, another having 117 mm thickness, would have the same efficiency at same velocity across the media. The problem here is that the pressure drop would change. If I would try to pull more air from a thinner HEPA, I would need to have that kind of pressures in my blower, so my power consumption, my sizing of the blower, and the noise, everything changes. So it has to be a match of right sized HEPA in terms of its filter media that it contains, and the pressure drop or the fan curves that you would size it for, and then you can do the things which is absolutely right.
Many thanks, Nishant. Another question which has been asked is, what is the media in thin HEPA filters and the thick HEPA filters?
The media remains same. There are different type of medias which are available within the HEPA, but that is not to take care of the efficiency. It is related to the kind of product that you're, rather the air that you're handling it, whether it's oil based, whether it is flammable kind of substance, solvent containing, or the kind of pressure drops. So there are different technologies which are available. Largely 99% people use a fiberglass based media, or there are PTFE medias also, which is Teflon media, which is available in HEPA.
Another question is, Nishant, in any existing split air conditioners, how this can be connected?
You need not connect it. The split AC works on a recirculatory mode, so does the air purifier works. let it remain in the same space, and both of them can do their job individually. What happens in a clean room kind of environment, we at times mix the kind of air or the purpose that we're looking at. So air conditioning would take care of reducing the temperature and controlling the humidity as per the specified limits, while the purifiers would take care of purification of the air. So both of them would work simultaneously on their own and do the job.
All right, last question which I have is, in which hospital has the system as mentioned by Vishal Kapoor?
I think so. It's proprietary information of that individual. It would not be right for me to communicate, and that's the reason that I've not named any of the installations. There are cases on one-to-one basis we can discuss, but on a public forum, it would not be wise to discuss on any of the specific names.
All right, thank you so much, Nishant. All those questions which were asked by our participants, I'm hoping that we have answered all such questions.
Thank you very much, Moin. If there is anything more that I can be of assistance, you can anytime ping me at nishant@degreeday.in. Thank you very much.
Thank you so much, Nishant. Thank you.